Welcome to my YouTube channel. The channel where we discuss mechanical engineering subjects. In today's video, we are going to discuss engineering metrology and practical number 6, measurement of the screw thread parameter using tool maker's microscope. In earlier video, we discussed screw thread terminology, where we take the practical demonstration from the screw thread. So we use this type of screw thread for the practical demonstration. Press the I button if you have not seen that video. So this is a screw thread for which we have discussed various terminology, that is major diameter, minor diameter, pitch diameter, or you can say effective diameter, thread angle, lead. So every parameter we discuss with the practical application. Okay. Now that video is for the definition purpose, in which you understand how we are going to define each terminology of the screw thread. Now today's video is different from the terminology. In today's video, we are actually going to check whether that major diameter, minor diameter are correct or not, or we compare it with the standards. For this, we require a tool maker's microscope, or even a profile projector will also does the same work. So what we are going to measure is shown in this figure. Suppose let's take this as a thread form. Now this is exaggerated, or you can. Now this is the thread form taken from this figure. Like suppose this is a bolt, a threaded bolt, where we have taken this piece and zoom it. Okay, so that's why you can see the bigger size picture. Okay, so what is measure diameter? Measure diameter is the diameter of imaginary circle which touches the crest of the thread for the external thread. Okay, so we have measure diameter from the crest towards the other side, from the crest towards the other side of the crest. Okay, so that is measure diameter. Minor diameter is from the root. It is again imaginary circle diameter from the root of the screw thread. Okay, so minor diameter is the diameter of the imaginary circle which touches the root of the screw thread. Okay, so this is minor diameter from root. In terms of external thread, from root it is minor diameter. That means from root to this root we have minor diameter. Then next is pitch diameter. Pitch diameter is where the pitch line. So from the pitch line we have the pitch diameter. That is again imaginary circle diameter which passes through the flank and from the center of the flank, or you can say from the pitch line. So that is pitch diameter. So three diameters: major diameter, minor diameter, and pitch diameter. Pitch diameter is also known as effective diameter. Okay, so we are going to measure these three diameters. Plus, one more thing is the depth of thread. Depth of thread starts from the crest and ends with the root. So it is the depth of thread. So depth of thread is there. Next we have pitch. Pitch is the distance between two successive threads if measured from the same point. That means if we have to measure the pitch between the screw thread, we have to take the crest of the successive thread, or for the root we have to take the root of the successive thread. Next terminology is thread angle and flank angle. Flank angle is angle with the vertical to the flank, that is flank angle. Thread angle is the angle included between two threads. So in this case, flank angle is half of the thread angle. So that is what terminology we discussed in the last lecture. In today's lecture, we are going to check and measure all this terminology with the help of tool maker's microscope. Now how it is work, what is the basic idea, practical demonstration. In the next half of today's lecture, in today's video, we are going to see the practical demonstration of profile projector, in which we actually see the projection of each parameter and how we are going to measure. For that demonstration, we required some concept to be clear. For the optical profile projector, one thing to be clear is the display. So on the optical profile projector, we have the circular display. On that display, we have two axes, horizontal axis and vertical axis. Plus that display has the graduations for the angular measurement. I suppose for the angular measurement, it has the graduations. Okay, and we can rotate this total disc with the help of this knob. Now for this Optical profile projector. Next important thing we require is the micrometers. Now on the screen, this is a display screen. On the display screen we have two lines corresponding to each axis. So vertical axis and horizontal axis. So when you move this micrometer M1 and this micrometer is M2. So when you move this M1 micrometer in this direction, the shadow obtained on this display device is moved by just M1 micrometer. And the shadow obtained on this screen is moved along the axis by this second micrometer. So basically, optical profile projector consists of display screen, micrometer for the vertical axis movement, and second micrometer for the horizontal axis movement. Okay. Now this is a display only. When you provide the input in terms of screw thread, this is only a display where we get the shadow image of the screw thread. Okay. So this is the display. So from the M1, we can move that shadow along the vertical axis. By the M2, we can move that shadow along the horizontal axis. Now let's take an example. If that thread form is giving you like this. So this is the shadow image obtained from that screw thread. Okay, shadow image of the screw thread on the display. Now take a look at this. Horizontal axis is touching to the all crest. When you move the M1, this shadow moves upward along this vertical axis. Along the vertical axis, shadow move upward. Horizontal axis remains static as it is. We don't move horizontal axis, or we don't touch this second micrometer. We only move this M1. When you move this M1, this will move the shadow image upward. Now how you obtain the reading? When the shadow image moves upward, this horizontal axis comes at this end, or the shadow image goes up. Okay, we get the second reading. And the difference between that two readings will give you measure diameter. Now here we have displayed the same with the again zoom manner, or can say with the again exaggerated figure. Okay. So first we take the measure diameter. What is measure diameter? Reading at 1, reading at 2. The difference between reading 1 and reading 2. So at 1, we have horizontal axis. We rotate this M1, we take the reading at 2, 2. So this red color is giving you the reading 1 and reading 2. So subtraction of R1 and R2 will give you measure diameter. And R1 and R2 is taken from this micrometer. Reading on the micrometer is the R1 and R2 for each location, 1, 1 and 2, 2. Second, we need to measure the effective diameter, or you can say pitch diameter. So effective diameter is, again we move this M1, we align that horizontal axis at the pitch or at the center. Then we take the reading at 1, 1, that is R1. Again we move this micrometer and align that horizontal axis at 2, 2, and that will give you reading of R2. Again you can see from the green color here, R1 and R2, difference between R1 and R2 will give you effective diameter. Next we need to calculate minor diameter. Again for the minor diameter, we move the axis, horizontal axis at the root. At the root, we take the reading at 1, 1, that is R1. Again we take the align at R2. Again we align at R2. So we take the reading at 2, 2. So second reading R1 minus R2 will give you minor diameter. So three diameters, we are only changing this first micrometer. Second micrometer is constant. Okay, we have not moved this vertical, or you can say we have not moved the shadow in the horizontal axis. We are only moving this and the vertical axis. Okay, so we get the three diameters: major diameter, effective diameter, minor diameter, just by taking the reading at 1, 1 and 2, 2. So difference between R1 and R2 will give you diameter. Next is the depth of thread. Depth of thread, again very simple. First we take the reading at the crest, then we take the reading at root. So we have measured the depth, taking reading at 1, 1. So horizontal axis at the crest and horizontal axis at the root, and taking the reading at 1 and 2 will give you R1 and R2, and that is the depth of thread. Okay, so 4 parameter we measured by the M1. Now for the pitch, we need to move this along the horizontal axis. This shadow we need to move along the horizontal axis. So that we require N2 in picture. So we move this N2, align this vertical axis to one of the thread, crest of one of the thread, that is 1, 1. Again move that M2, align it at 2, 2. So at 1, 1 we have taken the reading at R1, and at 2, 2 we have taken the reading at R2. So the pitch is again R1 minus R2 equal to pitch. Now the last parameter is the thread angle. For the thread angle, we must align this vertical axis to any one of the flank. Okay, now how you align this vertical axis? By rotating this knob. By rotating this knob, we can actually align that vertical axis. Now in this case, here you can see, we have aligned that vertical axis along this flank, and we have obtained the reading R1 at 1, 1. And second reading, we align the same vertical axis to the same adjacent flank. At 2, 2, we will get R2 reading. So again, R1 minus R2 will give you thread angle. Okay, so we have discussed 3 diameters, depth of thread, pitch and thread angle. So the major terminology is covered, and our practical outcome is also achieved. The practical outcome is we need to measure the various terminology using toolmaker's microscope. So practical outcome is we need to measure the screw thread parameters. Most probably the diameters, measure minor diameter and effective diameter, or you can say pitch diameter, by using toolmaker's microscope or optical profile projector. In the second half of video, now we will going to see the practical demonstration on the profile projector, that how we are going to measure each parameter. So you can see this figure and all these parameters. So this is profile projector 200 series model. First we will see each part of profile projector, starting from the knob and the start button. So this is the light switch button, this is stop button, and this is light intensity adjustment button. So we will start this profile projector. So this is light source. A beam of light is generated and it passes through the horizontal line, and it will deflect on the prism, and from this glass it is reflected perpendicular to this horizontal axis, that is at a 90 degree. And at the top of it we have the table arrangement. So on this table we have the screw thread on which we are going to measure all the terminology. This one is for the table movement in vertical axis. This micrometer here M2 is for the table movement in horizontal axis. So M1 and M2 are the 2 micrometers. Next we have workpiece, or you can say screw thread. For the comparison of size, you can see the size of that screw thread is similar to your paper pin. Okay. Then we have two magnifying 10x magnification device and 20x magnification device, for which now we are going to see in the 10x magnification device. Okay. Then next we have this projector screen, or you can say glass screen. On this projector screen we have vertical axis. So this is vertical axis and horizontal axis. Okay. Plus this screen is graduated for the angle measurement. You can see the graduations. So starting from 0 up to 180, 182, again up to 360. Okay, so this is the main scale, and this one is vernier scale. You can see here 1 division equals to 5 minutes. Okay, these are the connectors for the attaching trace paper or for the comparison purpose. We can move by this knob. We can move that angle by this knob. Okay, so normally we set it at 0 degree. Now how we are going to measure each parameter? We first mount this screw thread on this work table. Due to that, the contour of the screw thread will get reflected as a shadow on the projector screen on this glass. Okay. Now we have situated the screw thread on the work table perfectly so that all thread form or the crest of the thread will touch to the horizontal line. Okay. So this you can see, it is all the thread forms are in the horizontal line. We take now first reading, that is R1. R1 reading taken on the micrometer. Okay. So that is R1 reading. Then we move the micrometer. Then we simply move the micrometer. That will move the shadow upward. That will move that reflection upward. And we again align, move upward, and that will again align the next set of threads. That is this point. So we take this now second reading, that is R2. So the difference between R1 and R2 will give you major diameter. For the minor diameter again we set this at root of the thread. Root horizontal axis at root of the thread. Okay, and we take the reading as R1. Then we move this shadow image along the vertical axis. That will align the horizontal axis to the root of the next thread. Then we take the second reading as R2. So we are only moving this M1 micrometer. Okay, so the difference between R1 and R2 will give you minor diameter. Now for the effective diameter, we pass this horizontal axis at the middle, at the center. So now take one reading, that is R1. Then move this micrometer. Take the second reading. Take the second reading where horizontal axis is at the middle. Take the second reading from the micrometer. So the difference between R1 and R2 will give you effective diameter. Again similar procedure for the depth of thread. Take this reading where all horizontal axis touch to the crest of the all thread. Take it as R1. Then move this micrometer. Take the second reading at the root. That is R2. Difference between R1 and R2 will give you depth of thread. Okay, so we have measured 3 diameters from this M1 just by moving this shadow image on the projector screen. Now for the next terminology, that is pitch, we need to use second micrometer. That means in this micrometer. So this micrometer actually moves this table longitudinal, and this micrometer will move the table crosswise. Okay, so this micrometer will move the shadow image on the horizontal axis, like you can see. If I move this micrometer, this image will move. Okay. Okay, so for the vertical, for this movement, for this micrometer M2, vertical axis or the shadow will move in along the horizontal axis. Okay, so we align at one point vertical axis, one point, any point, crest point of the thread, and we take the reading from the micrometer. Now we will align to the adjacent thread form on the same crest. Now we again take the reading from the micrometer. So the difference between reading 1 and reading 2 will give you pitch. Okay. Now last parameter is the thread angle. For the thread angle, we need to align this to any one of the flank. Now for this we need to rotate to get it aligned. Now it is away from the flank, so we can take the help of this micrometer so that it will get aligned. Okay, so now it is perfectly aligned. You can see it is perfectly aligned with the flank. Now take the reading from this 0 coincide with the 340. Okay, now we align this vertical axis to this adjacent flank. So we align this to the adjacent flank and note the reading. Okay, and the difference between two readings from 340 to this reading will give you the angle of the thread. So that's it. I hope you have enjoyed this video, and practical demonstration also we have covered various angles how we are going to measure. You have seen a real optical profile projector and its projector screen, and 2 micrometers how we are going to align it. Plus we also discussed about the angular measurement. Okay, so that's it for today. If you like this video, please like, share and subscribe to my channel, and also follow me on Facebook, Instagram and Twitter. Thank you.